Response video to some of the comments on the in Mendham video requesting explanation for why if you aim the photons in the two-slit experiment, traditional two-slit experiment, why doesn't it work? I mean, why does the photon care? Yeah, and yeah, the explanations suck. Trick just points out they agrees that too many people are full of shit on drawing conclusions based on quantum mechanics, which is just math. Anyway, and the rest of these answers are crazy. But anyway, because if you aim such a way that it is possible to predict through which slit the photon goes, then it will just do that. Look, the point is that this, the detector argument, okay, that somehow if you detected the photon or attempt to detect the photon for position information, that you collapse something or you break something, or that's why it doesn't work. My argument is that this prediction is a theoretical prediction. It has no mechanical correlation. There's nothing mechanically you're doing except using a gun that fires straight. So why is using a gun that fires straight violate quantum mechanics? Why does all of a sudden the photon have a different character? I mean, it's you can't argue that there's interference through. Again, prediction was always based on the fact that you would physically manipulate the photon to find out where it was. You're not finding out where it was. You're just making sure you know how you aimed it. There's a difference, a big difference between those two things. Alright, Object 99 just types a whole big pile of crap, and it's just, what's the point? Historically, a lot of people use the claim of Copernicus predicts the same thing as MWI, but different physicists who claim to subscribe to the Copernican approximation often disagree with each other about how to define it. Well, yeah, I know, it's all vagueness. Anyway, but just all this isn't an answer. It's just a huge pile of crap that doesn't answer my question. Anyway, so yeah, fuck it. This answer is some sort of traditional blah blah. I'm an asshole, but here's my answer. Aiming the gun does fuck the experiment. I don't know enough to burst out some lex, but I think it work done around many worlds. I mean, many worlds is just absolute nonsense. It has the math. I'm sorry, it doesn't. You need to answer the question. It replaces collapsing the wave function with quantum decoherence. Well, this isn't, again, you're not explaining why the photon is different when it's aimed. The only way it works is as if things go particle, field, particle. Well, field would be what? Oh, that's interference with something again. Oh, so again, that makes my argument for me, that the only thing this two-slit experiment is demonstrating is interference that's happening in the creation of the photon. In other words, at the source you have a particle. Between the source and the detector you have a field. Well, you don't have a field, you have a hole that the photon is forced to travel through. And finally the detector, the observed effect again, the particle. Yeah, whatever. Not a good answer. What do you do for a living? I'm curious. It's just, these people are just so obnoxious. I don't have time to think much because I've got to go earn money and pay bills. I mean, it's just so obnoxious. I mean, really, did Grandpa leave you money? No. I mean, my lifestyle is pretty obvious. I live a meager existence, and I work meagerly to pay it, to sustain myself. It's just rude. I'm not voting for the capitalist system, so the fact that you're part of it that's your business, fuckhead. Some people have jobs where they can think, some people don't have jobs where they can think about other things, and I think that's just horrible. I've lamented the fact that, yes, if I had to work 8 hours a day, I certainly couldn't do this. Somehow that makes me wrong about something? Oh, no, it doesn't. You're just an obnoxiously rude motherfucking cunt. I think I will, appropriately do the appropriate thing, Gary. Just say, fuck you. I mean, really, not on sub. PM me. Why would I PM you, you lousy motherfucking cunt bastard? I mean, you rude motherfucking irrelevant scumbag. PM you? Fuck you. She. Yeah, God. This picture of Nietzsche, I think. That says it all, right? Rude and Nietzsche. Yeah, that goes together. Anyway. Ugh, people suck. So, all I wanted to add to this conversation is, you know, in thinking about, okay, so here's just, I'll do this little quick diagrammy thing. Let's just get this done with here. Alright, you have your source, you have the hole, you have your two slits, and you have your target. Okay, so the problem is that I'm saying the first part of this experiment, right here, you have a problem, okay? Not aiming and then forcing photons through a little hole, and as Feynman says, a large distance between this and this, and then a large distance between, no, a large distance between this and this, and a large distance between this and this. Anyway, so what I would speculate is happening is that, you know, the photons are being diffracted on these edges, and that's the substance of the interference pattern you're getting. And I guess I would argue that we know that light does this stuff. You know, they could call them Newton rings or whatever. But there's this idea that light, well, Newton's rings are more like the two-slit experiment. It's an interference pattern. But we also know that light will do this ringy thing, you know, in terms of its intensity when it goes through any kind of object that has a shape, that the shape will create diffraction at the edges and will increase the intensity of light. So it's sort of a banding effect. Obviously, if you take the circle out of here, you end up with a banding effect. So that's what's happening here. So if you took a visual of if they put a film in front of the two-slit experiment, you know, in front of the two slits, what kind of pattern of light is hitting this slit, these slits? I would argue that the two slits, if we drew them here, and then we say, okay, the light's coming at the two slits through this diffractor, and then what's really happening is one of these rings is right on, is the exact dimension of the outside of the two slits. So it's the exact size of the outside of the two slits. So the most intense light, 40% of the light, or whatever you want to say, is hitting the periphery of the slits. And that's doubling or magnifying the refraction that's going to take place on those edges. So you're just maximizing this effect. It's really just a magnifier for the effect of light that it does concentrate in terms of its probabilistic trajectory whenever it encounters an object. Yeah, I think, and so that pretty much explains that. Now the other element that I'd say that's really quantum mechanics. So when you talk about quantum mechanics, what quantum mechanics is about is it's just talking about the interaction of photons and electrons. And you know, you have to think that all these surfaces, like any pinhole I make or two slits, the matter that makes these things up is matter. It's not a solid thing. Atoms not only have a shape, you know, like oxygen, they also are moving constantly, jiggling in all, you know, in specific directions, but, you know, random from our perspective, not random from their perspective. So they jiggle, they vibrate at frequencies, many frequencies, harmonics of those frequencies, and at the same time they may be doing, you know, spiral moving. So their configuration can move also, depending on the kind of medium the light's traveling through. So position can be changing also. So position, so say if I'm a photon, I'm coming towards a surface, a material surface, I won't know where exactly the position of, let's say, the atom I'm going to encounter. Its position could be here, or it could be a little bit forward of here, or it could be a little backward of here. You get this? So it could be any direction, it could be anywhere in here. My trajectory is set. the thing I'm going to hit or encounter is not set. It's moving, it's vibrating. And so this is the origin of the probability described by quantum mechanics. Quantum mechanics merely gives you a description of your probability of encountering the atom in any one of these positions. So the atom's more likely to be in one position, center let's say, than it is on either one of these outsides. So these would have smaller vector arrows than this middle position, because it's in the middle position twice, as it goes both ways. So quite obviously, being in the furthest away position and being in the closest position, these might be things that it's, half as likely to be in as one of those center positions. So here you have the origin of the, light banding and intensity kind of thing, where there's a high likelihood here and lower likelihoods going further out. And it's the same. So just by modeling that one feature, you can sort of understand that depending on the position of this atom, this photon will more likely hit an electron in different conditions. Maybe the electron's over here, maybe the electron's over here, over here, over here, over here. This is what quantum mechanics is describing, is the fact that the thing being interacted with is in constant movement. So quantum mechanics is really a description of the consequence of the fact that all interactions, light interactions with matter, are interactions with something that's moving. Okay, it's going to change its position with each incident of time. This circumstance is going to change. It will interact with something different on this atom depending on the integral of time. And so Feynman breaks that down to a clock. He just describes it as a clock spinning. So what he's basically saying, as you move through time, your probability vector will get longer, 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 and its direction can change. So when it gets shorter, shorter, it goes to the opposite direction, longer, longer, longer. And so this is the nature of creating the probability wave function. It's not a function. The wave is not a function of the photon. It's a function of what happens to a photon when it interacts with something that's moving. So the wave function is a description of interaction with moving objects, that when you, obviously things that are moving have the wave in them. This is where the wave comes from, is the thing it's interacting with. And all of these things, here with the slits, and even here at the target, there is an interaction with matter, and this same probability effect is going to be multiplied. So you have 3 probability effects in just this, and then you have also the creator of the photon. So this is what's being amplified and demonstrated through this filtering, creating what's called this interference pattern. But the interference pattern is just a reflection of the fact that there's a constant and predictable movement of the matter, and that movement has specific wavelengths, it has specific timing cycles, and it's completely predictable in terms of overall probability that it's going to be in a certain position more often than it'll be in another position, and then the photon's destiny is going to be decided by the position of this matter it's going to interact with. So it's the matter that's imposing the function. And the same would be true about the target, what percentage of photons are actually absorbed and which percentage are reflected. And there's lots of questions that can be asked about whether the photon is going to be recognized as a photon, based on what it actually hits. I mean, they're all targets. There's no substance on Earth, I don't know of anyway, that doesn't generate some heat. As I guess I could do heat with a thermometer. you know, that some heat's going to be generated when you bombard it with photons, and that heat would might represent photons, you know, completely absorbed, you know, in some way that you're not going to be able to recognize detection, you know, with some sort of electrical change or some sort of change in the chemistry. Yeah, no point in going that. I just don't know if there's anything that's 100% absorbent, but I suppose there is. No, I won't. That's not necessary to my point, so let's not even play with the target's irregularities. We already know the irregularities of the slits and the fact that they've been designed to create interference. And this focusing hole, you know, the beam shoots out like this, and only a tiny percentage of what it shoots out is allowed to get to the slits, and that can be manufactured to maximize the percentage of light that's actually hitting the outside edges of the two slits. You know, these edges. So this would be. So anyway, augmentations to the experiment that I would like to see would be put a photographic film in front of the two slits and view the pattern of light to see how much diffraction you're getting from the actual source light. Another way of doing this experiment I'd like to see done is, I've never heard of it being done, I'd just be curious. You know, there's lots of transparent, you know, mostly transparent films that will change the color of light. So if they put a red filter and a blue filter, let's say, you know, over the slits, we should see a subsequent blending of those colors in the result if the particles are going through both slits. And that would be a way of detecting, yes, but more importantly, it'd be just curious to see if that also breaks the two-slit experiment, whether the pattern is somehow affected by transparent films put in front of the slits. I mean, I've never even seen it done, just even a solid film, just a solid transparent film put behind the slits. Would that ruin the experiment? I've never even seen that done. And if a solid one-color film doesn't destroy the experiment, I'd just be curious to see what, you know, it would be curious. I would be curious. That's all that needs to be said. I would be curious. Even a film in front of the target would be interesting. You know, film, put a plastic film in front of the target. Does that change the result? Yeah. Anyway, so many ways to augment this experiment. It's a 100-year-old experiment. It's critical to modeling atoms and their interaction, energy and its interaction. It's just so fucking important for people to understand what's causing the pattern, and yet no one's doing it. I mean, all these universities and shit, they got all these lasers, they got all this crap, they're doing all this high energy this and super collider that, and they can't just make these experiments and do them in a myriad of different ways to demonstrate, to attempt to demonstrate what's actually happening. I mean, I'm going to have to fucking finance this or something. Why does this not? Why hasn't this been done? It's just so irritating that physicists are comfortable with their science being blighted by all this bizarre speculation when they could do experiments to firm up the evidence about what's really happening and what quantum mechanics is really about, which is just probability math, because photons only interact with things that are moving. It's a fact. Yeah. So anyway, until next time.